In this series, we'll build a modern real-time chat application using some of the most popular server-side tooling currently in use. We'll be using Python for the web server to facilitate WebSocket communication to a frameworkless web client. Our app will feature instant messaging, user authentication, live online user tracking, and encryption for private messages. Server-side will be using popular tools such as FastAPI, Bcrypt, Pydantic, SQL Alchemy, Python Jose, and PassLib to create a feature-complete project. This application will fully include industry-standard design features as if it were a full commercial product. We'll include comprehensive security features like password hashing, JWT authentication, asymmetric encrypted messaging, and we'll go over some important concepts such as input validation and CORS protection. By the end of this tutorial, you'll have added a production-ready real-time communication application boasting advanced security implementations that demonstrate modern full-stack web development best practices. I'm going to have these hosted on my website here, so I'll have the link in the description here, but that way you can come through and get just a text version of this tutorial, and then you also have a little copy button here too. Then I do want to go over the app flow. It's going to be kind of boring. I'll try to go quick, but it's kind of important to understand. This will be available too, link in the description. So the logic of this app is going to have kind of like a particular flow, like certain things need to happen in a certain order in order for all of these features to be implemented correctly. So upon initial connection, the user is going to visit the registration page, register, fill out the form, and then on the client side, we'll do some JavaScript validation. And then the client will send that registration form to the server. The server is going to check to make sure that there's no username clash in the database, and then it'll hash the password that the client provided and save that in the database. That way, the only time that the actual text password of the client is on the server is in process memory, and it doesn't get saved anywhere. That way it's not stored on the server in an insecure way. So if that's a success, we'll save the user to the database, send back a response to the client, and then redirect the client to the login page. Once the client gets redirected to the login page, they'll enter the credentials, so they'll send it to the server. Then the server will do some validation to check the hash password against the supplied password, and then log in the user. And at that point, as long as everything's okay, we will generate a JSON web token. We will return that to the client, and the client will store that in the client local storage. Then we'll be redirected to the chat page. So when we visit the chat page, the JavaScript will be checking that JWT to make sure, for one, it's valid on the user that it's assigned to, and then also it's not expired. We'll get the current user info, validate that JWT, and then we'll fetch the user ID from the database, and we'll update the UI with the user info. Then we will initialize the WebSocket connection. On the server side, when we create the WebSocket connection, the server will accept it, validate the JWT again, and then it'll be passed into the connection manager, which is just kind of our abstraction to handle all of the user connections. So then once the user is added to that manager, connected clients, that's a new user has joined. And then a list of online users will be returned. That way we can populate the online users list. And then that's essentially the connection established. The real-time messaging flow is gonna go like this. So the user is gonna type a message and send it, which is going to create a message object on the client side. And then the client WebSocket will send that to the server for processing. And then that message will be broadcast to all users in the chat. Each client will receive that message, and then the client will process that message and then display it in the actual chat interface. It's just kind of important to understand like the directional flow of how all this works, because we have that JWT authentication, and we have logins and registration and stuff. So, and so to make this a little bit easier, I provided this script here that'll set up this entire project for you. So we'll just, I would just recommend going to you can try to follow along and implement these directories yourself, or you can just go to my website and then copy this, and then in a new project folder, make something called tools.py. This file is like not permanent, doesn't need to be permanent, but it's useful currently for the project setup. So when we paste in that code to our little temporary file here and run it, it'll create the entire project directory structure for us, which is nice. Which is obviously all the Python server-side stuff, and then it actually also generates the static JS, CSS, and HTML for you. It pre-populates a few things in the .env, mainly what that tool does as well. If we look at it here, one of the ways that you handle encryption is by giving a custom secret key. We're gonna go ahead and generate a random secret key here, and that just gets pre-populated here. Other than that, it also pre-populates requirements.txt. And one of the first things we're going to do is set up a virtual environment and install these dependencies. So we're going to python-m.venv in a second. And then we will activate that virtual environment. And then we will pip install -r requirements.txt. So one of the first things we're going to do is set up configuration management using Pydantic, which is just nice because it'll allow us to, it'll let Pydantic work with and deal with our environment variables in a type safe. That's going to be an app utils config. We have a couple imports here. And then we'll create a class, settings, yep, base settings, and then we'll do project name. Yeah, this looks right actually. We've got project name as a string, but I don't want to have any of these. We're gonna have environment variables. We don't need any of these function here, and it's gonna be a property. First allowed hosts. Yep, it's gonna turn strings, and then host strip. Yes, that looks right. Then at the end, we're going to create a variable that we can access. Settings equals settings. The next step is with our settings class in place, we need to deal with our environment variable. I'm going to go ahead and copy and paste most of this. You guys can follow along and just type this out. But this is just stuff that we're going to, a lot of it's obviously we have the secret key that's passed to the encryption algorithm and the database URL. A lot of this is just kind of like boilerplate information, metadata pretty much for FastAPI. Allowed hosts, this is just going to be the CORS policy essentially. So if you're going to deploy this on an actual server, you would want to add your server endpoint here as well. You might want to, I don't know, it depends on if you're going to do reverse proxy or not, but, and then obviously we got the database URL. This obviously, you could also plug in Postgres or something like that if you wanted to go that route, but SQLite's simple and fast and easy to just start up with. Have some imports here as well. And then we're going to do the basic database setup. So SQL Alchemy database URL. So we actually don't need this default engine, we create engine. Yep. Then we'll use that. Go Alchemy. This either, and then we'll create a session local. Local. Going to be equal to session maker, auto commit false, auto flush false, bind engine, yeah. And then we'll create a base object for the declarative base from SQL Alchemy. And then after that, we will kind of initialize the database. So we'll do get database, correct, db get close. Oops. And then, well, I guess this is kind of like the lifetime cycle for your database. So you'll close your cursor before the actual program finishes if you exit gracefully. And then we'll do an initdb, and that will just be base metadata create all engine correct. You spell this correctly. With the database complete, the setup complete, anyways, we'll create our user model with SQL Alchemy, which will basically define the structure of our users table. Which will be pretty simple. We don't really need much for this chat app at the moment. That's going to be an app database as well. We can add these at the top. I think they're already up there. Yeah, they are. So here we'll just do class user. That looks mostly right. We've got the table name is users, ID is going to be, this is, we're going to change this and be a little bit more explicit. Integer primary key index, correct. Did I not import this? Column. We already have that. Right? Yeah. And then the username is going to be a column as well. Column string unique through index through nullables. We're gonna add nullables false though. So we can't have a null value for a username in the table. And then we'll have a hash password, column string nullable false, and then no email. We will have a created at column string. Actually, we need date time. Actually, this is not a string; it's a date time object. Duh. Column date time zone equals true. And then server. If I typed it, holy crap. Server default. This is the SQL function that gets run to populate this on creation. And then we don't need this either. Oh, no wonder this is giving me crap. Here we gotta. These is equal. Excuse me. And then we need to import this as well. It's capitalized. And then finally, we're going to set up the CRUD operations model for the database here. We're going to have a get users db, which is type session. And then user ID is going to be int. Import that. There we go. And then we will also have a get user username correct. DB session username is going to be string. It's going to query for the user and filter by the username. Well, filter on equality of the username. It's going to take the first one. And then we'll have get a single user. DB session user ID int, and then we're also going to get the hash password. It'll be a string at this point. And then we're going to return the DB query on the user. Offset skip. Oh, I spelled offset wrong. Offset skip. Limit all we need to import. And we need to import skip and limit here. That looks all good here. Create the user. The DB is going to be session. Username is going to be user name. Going to be a string, and the hash is also going to be a string. Yep, DB user. It's going to be a user model. Add it to the DB. We'll commit it, refresh, and then we'll return to the DB user. Create the user. The DB is going to be session. Username is going to be user name. Going to be a string, and the hash is also going to be a string. Yep, DB user. It's going to be a user model. Add it to the DB. We'll commit it, refresh, and then we'll return to the DB user. So since there's no point really just watching me type all these data constraints, I've got this implementationless file here. Basically, we'll just kind of go along each one of these models and go over what it does real quick, and then we'll kind of get that whole data wrangling out of the way kind of quickly. So the user base is the base user model for shared fields. We've got the username field with these, and this annotated. Annotated is like Pydantic's way to attach metadata. It's obviously Python's not a statically typed language. We don't have to normally define these things prior to runtime. But basically, what annotated does is it annotates this base model as a class with these with this field, and then it attaches this metadata to it. Basically, so not only is it a string, but it attaches some information that tells the application basically at runtime that not only is this a string, but it has these constraints where the minimum length is 3, the maximum length is 16. It's going to script the white space, and then we have this this field object here, and it's basically also attaching metadata. But the cool thing about this in particular is it kind of gives the Swagger OpenAPI documentation a little bit of superpowers, so you can go to the /docs endpoint. You can kind of get some information about some of the models. The field validator is on the username field, and it's just going to normalize the text entry to be lowercase. And then we have the user create model here. Same kind of thing. We've got a password. It's a string. It has constraints. Same kind of description or metadata description here. We have a user model here. And this is for the API responses. So this is the model that doesn't include sensitive data, no passwords or anything like that. So it's got an ID, which is an int, and this is another way to attach this metadata to the field. We have a datetime object, which is created at, and we have this model config. So frozen equals true will mean that it's essentially like an immutable object once it's created. So you can't go and change these fields later on in runtime after it's created. And this from attributes and JSON encoder, it allows SQL Alchemy's ORM essentially to serialize the date time to an ISO string built off the ORM. like it loads from the ORM. And then we have a token, and then we have the token, which is a JWT access token, which is going to be, it's going to be passed as a string. It's going to be a string value. Token type, typically bearer. It has an expired then optional field, because you can get that out of the JWT itself. Same thing with the frozen equals true. Same thing with the frozen equals true. This is just makes it an immutable. Once the object is created, it basically makes the field immutable. And then we have the WebSocket message, which is just our base WebSocket implementation. So we need to go up here and do this first. So I skipped this kind of on purpose because this is kind of a cool way to define your depending on how you structure your WebSocket communication. Typically you'll have your type be like an event type or something, and we're going to define those here, and then we're going to use this enum class to ensure that these enum values and only these enum values are valid values for the type, or for the type parameter on these models here. So we've got message, get online users, user joined animation, online users, and an error. So those will be the types of WebSocket events that we send back and forth. Yeah, so we've just got the message type like we just talked about, and it's going to have an optional timestamp, and we'll have a default factory which basically waits till runtime. Actually, it waits till object creation during runtime to invoke this function here. So we have it as a lambda, which is just going to create a Python datetime object as the value for this timestamp field. First equals true. We already talked about that. JSON encoder essentially lets us translate the timestamp to an ISO format, which is something that we can actually communicate with over the network. Obviously, we can't just send datetime objects over LAN. We're gonna have the same message type constraints here with a default message type of message. Then we're gonna have these constraints where the minimum length has to be 1, the maximum length is 1,000. We're gonna be white space descriptor for that, and then the user ID and the username are going to be field values, int and string respectively. User join message. Again, we got the type constraint for the default user ID, username. Pretty simple. Pretty simple. Once you kind of get your head wrapped around how and why Pydantic exists, for one, it's super powerful. And for two, it helps you really kind of architect the way that your application event communication is going to run. Where we at? So online user. Yeah, same sort of thing. Once we have an online user model created, we're not going to need to ever change the values of these fields. So we're going to freeze them in string online user message. Same thing, message type constraint with the default. And we're going to have the field is going to be a list of online users. And then lastly, we should never hit this, but we're going to have it just in case. Through WebSocket messaging, you're receiving communication as JSON. And when you use Pydantic models to parse and validate them, the validation happens after deserialization, but before object instantiation. So essentially, we get the information over the network, and before we waste all the time making the whole object and doing the validation after we create the Python object, which is one of the slow things about Python, we actually use Pydantic to validate all inputs before instantiating objects. So it checks types, it applies constraints, it runs field validators, and only then it doesn't create the Python object, or otherwise it raises a validation error. And that's why we actually had to implement this last thing here, because we don't want it to just crash. We want to be able to tell the client, hey, you messed up on whatever communication you sent to us, and we're not going to accept it. So I made a test script. That way we can test the implementation, the features we just added, which is good because it pointed out some of the errors that I made in the code I presented on the video. So if you just go to my website here, link will be in the description. We can just go ahead and copy that code and then make a new file, test features, just in the root directory. You can paste that in, and then we'll go over the mistakes here. So this here should be get user, because we're only getting a single user here. And this one should be get users. And this is the way this is implemented, is set up to support paginated responses to get the users. These will be parameters to the function. So skip will be default int 0, and then limit will be default int 10. Oh yeah, and on top of that, I denoted the type in a lot of these as the Python string object, and it's actually going to be a SQL Alchemy string type, and then this function actually I think gets imported from, yeah, SQL Alchemy.sql import func. We'll fix this here, changing these from Python types to SQL Alchemy types. Oh yeah, in the config here, I have this as a list of strings, and in our .env file, it's going to be just to be just a string, comma separated, which is what we do here. This test feature will just basically go through everything that we've implemented already and then just run it and give us a response that it worked, and just so we can verify that everything that we did so far actually works. As you can see, our little test script verify that all of the implementations that we went over actually function.